Stranded versus bundled conductors. In the world of electrical wiring, conductors come in various shapes and sizes, each with its own strengths and weaknesses. Today, we'll delve into two popular types, stranded and bundled conductors. While they might sound similar, there are key distinctions to understand when choosing the right conductor for your project. Stranded conductors, flexibility is king. Imagine a single, solid wire. It's strong and efficient for carrying current, but bend it too much, and it snaps. Stranded conductors address this limitation. They consist of numerous thin wires, typically copper, twisted together. This creates a cable that's far more flexible than its solid counterpart. Benefits of stranded conductors. Bending champion, their flexibility makes them ideal for applications involving movement or tight corners. Think appliance codes, power tools, and intricate electronic wiring. They can navigate complex layouts and endure the constant flexing that would cause a solid conductor to fail. Vibration resistance, they can withstand vibrations and flexing without breaking, making them suitable for machinery and equipment. This is particularly important in applications like generators, motors, and portable electronics that experience regular vibrations during operation. Downsides of stranded conductors. Current capacity. Each thin strand carries less current compared to a solid conductor of the same diameter. So, for high current applications, thicker stranded cables might be needed. This can translate to a larger cable footprint compared to a single solid conductor carrying the same amount of current. Connection challenges. Terminating stranded wires can be trickier due to the individual strands. Special care is required to ensure proper connections, as loose or broken strands can lead to increased resistance and potential overheating. Soldering and crimping techniques need to be adjusted to accommodate the multiple fine wires. Cost factor. Manufacturing stranded conductors is generally more complex, leading to a slightly higher cost compared to solid conductors of similar size. Bundled conductors, combining strength. Bundled conductors take things a step further. Here, we have two or more stranded conductors grouped together, typically with a small air gap separating them. This configuration aims to increase the overall current carrying capacity of the cable. Benefits of bundled conductors. Supercharged capacity. By combining multiple conductors, they offer a significant boost in current handling compared to a single conductor of the same size. This is crucial for high-power transmission lines where vast amounts of electricity need to be delivered over long distances. Improved line efficiency. The spacing between bundled conductors reduces the line's inductance, a property that can hinder efficient current flow. Lower inductance translates to lower energy losses during transmission, leading to a more efficient power delivery system. Downsides of bundled conductors. Installation complexity. Installing bundled conductors requires more planning and specialized hardware compared to single conductors. The spacing between the conductors needs to be maintained precisely, and specific clamps and connectors are necessary to secure them to poles or towers. Space considerations. The spacing between bundled conductors necessitates more space for the overall line compared to a single conductor with the same capacity. This can be a challenge in areas with limited space availability, such as urban environments or congested corridors. Choosing the right conductor. So, when it comes to stranded versus bundled conductors, the choice depends on your specific needs. Prioritize flexibility. Stranded conductors are the clear winner for applications requiring frequent bending or movement, such as appliance cords, power tools, and intricate electronic devices. Maximize current capacity. Bundled conductors are the go-to option for high-power transmission lines where maximizing current carrying capacity is critical. They are also employed in some medium voltage distribution applications. Consider installation complexity. If ease of installation is a major concern, stranded conductors might be preferable due to their simpler handling and connection requirements. Evaluate space constraints. If space is limited, stranded conductors might be a better option due to their smaller overall footprint compared to bundled conductors with similar current capacity. Conclusion: by understanding the strengths and limitations of each conductor type, you can make informed decisions for your electrical projects. Whether you are designing a power cord for a household appliance or a high-voltage transmission line, choosing the right conductor ensures efficient and reliable operation.